Hi everyone, a big hello to all of you. I'm Janice from Google Developer Relations team, and thank you for joining our very first La Kopi Online. We're so glad to be connected with you here, even though it's just virtually, and we hope everyone is keeping safe and well in these uncertain times. Please help us give yourself a big hug. So in case we have friends who are joining us for the first time today and had never had the opportunity to come down here to Google Developer Space for the last 8 La Kopi sessions, let me share a little bit about who we are and what this is all about. So Google Developer Space is a home for developers and startups from all around the region to learn, connect, engage, and be inspired. Last year, we engaged with over 15,000 developers in person at our 180 events here, right in Singapore, empowering and connecting our community to our people, programs, network, and technologies. La Kopi at Developer Space is our monthly open mic night. We select a tech team, this month being data science, and speakers submit their topics to share about best practices, ideas, projects built on Google Developer Tools. This month, the topic being data science and also it being March, and we're celebrating and highlighting women's contributions to the world. We have with us 3 amazing ladies joining us tonight. So our 3 speakers are Pascale, a data scientist at Holmusk, Priyadarshini, CEO and co-founder of ExploreMaps, and Vaidheeswaran Archana, master students at NUS. They will each be sharing for 10 minutes, and you're welcome to submit your questions on our YouTube live chat, and we'll answer after each and every speaker. So without further ado, let us welcome our first speaker, Pascale, who will be sharing with us about how Singapore startup Holmusk is transforming lives with behavioral health. So over to you, Pascale.
All right, so hi everyone, I'm Pascale. I'm a data scientist at Holmusk, and I'll actually be joined for the Q&A with 2 of my colleagues, Jawei and Srinash. So what we've actually tried to do at Holmusk is look at how we can actually derive information from imaging on, most particularly on Alzheimer's disease brain imaging, and then map it to a cognitive state. So some of you may be familiar with the Alzheimer's disease. So here in Singapore, as well as worldwide, there's actually approximately 35 million cases of AD. And within the next, few years, within the next few years, it's estimated that it will come up to almost 106 million. So currently, the cost and burden of dementia is very large. It goes into billions, and it's thinking that within the next couple of years, it'll go to trillions. Now, why is it so important to look at Alzheimer's disease? Well, it causes major atrophy throughout the brain. Compared to other diseases, Alzheimer's disease has no drugs that have been approved since 2003. So it remains an incurable disease. So AI is one of the strategies that have been used to look at how we can actually find more cures and how can we actually help the population that will have Alzheimer's disease. So the current models, what they use is 1 or multiple inputs, such as MRI, genetics, CSF, and cognitive scores. And then they use deep learning neural networks, and then they predict, the diagnosis or the risk of onset. Now, the limitations of such models is that, they are great diagnostics tools. Right now, they achieve, more than 90% accuracy. But the problem is that a lot of the time they use 2D imaging. 2D images actually ignores the spatial relationships of brain regions, which actually diminishes how much insights you can really get. And they also only look at MRI and not PET scans, which are more limited in numbers, but they are more rich in biomarkers. So what are we trying to do at Holmusk? We're trying to identify the relationship between cognition and brain biomarkers. So when you're suspected of having mild cognitive impairment, what you do is that you go to your doctors and they give you this test called ADAS-Cog. It's composed of 13 questions. What we wanted to know is which of those questions are actually the most predictive of Alzheimer's disease. So we selected 4 of them. most of them are actually in memory and learning, so they're called recall. And other of them are more into problem solving and word recognition. So we use simple models such as random forest and XGBoost to look at the important ones. Now what that does is that now we're trying to say, well, what in the brain could actually predict this cognitive score? So what we have is actually a model that incorporates 3D images. We can use 3D images multimodally. So what that means is that instead of using a 3D input, we use a 4D. And if you guys know the RGB aspects, is that you can actually, instead of having R, G, and B, you actually have channels for an MRI, a channel for a PET, and another channel for another PET. And the composite of that will actually predict the score. So we used a CNN with inception units and a ResNet skip connections. And then we can do two things. One of them is that we can actually have fully connected layers and predict the ADAS cog score. In this case, we actually have 4 different regressions that come out of it. The other aspect that we can do is that we can look further into the brain and say, hey, which regions of the brain were actually important for question 1, question 4, question 7, and question 8. And from this, we're able to actually generate a mask that can extract biomarkers. The other aspect that we can do is that we can just use the fully connected layers to make a classifier and then identify whether our model is the same as other models as well in terms of diagnostic tools. So these are our model predictions and what we got. So what we saw is that the imaging that we were able to give them were quite good in memory and learning. So we were able to achieve an R-square of 0.8. But it was less good in aspects such as problem solving. So the issues here is that word recall and delayed word recall have memory and learning components, but really which brain region is really for problem solving? It's most likely a large area and very, very complicated aspects. Well, what does this mean? I mean, you're putting some images and you're trying to say this is the score. So as I said, when you do the testing, what happens is that your doctor will give you 10 words. So these are kind of 10 examples of words. And they'll ask you to remember it, and after 3 minutes, they'll say, how many can you remember? So of all the people that we have here, how many do you actually think you could remember as a healthy young adult? So what can our model do? What our model does is that we give it brain glucose consumption, simply, and this is an FDG PET. We put it in a CNN model, and then it can predict the words that you can remember, plus or minus 1 word. So I could say from this brain scan from this one person is actually 9 words, or maybe 8 or 10. But this other person here would probably remember 5, plus or minus, 4 to 6, which is actually quite exceptional considering it's just a brain scan. So the other aspect that I talked about is the GradCam, which is a really nice thing when you're talking about cats and dogs. So if you're trying to identify this is a tiger cat, then you can have, oh, this is a cat, and this is the region that the model was looking at to actually predict a tiger cat. But for brains, how does that work? So this is usually the images that my team works with. So we have a cognitively normal brain, and it's a SPET scan, and then we have an Alzheimer's disease brain. After a lot of processing and image registration, this is what it looks like. Now with the model, what it does is that by using or leveraging GradCam, the model was able to say, okay, for Q1, these are the regions in a 3-dimensional mask that are important. But for Alzheimer's disease brain, it's looking at something that is completely different. So we're able to say, we're going to extract information from those 2 brain regions. So as I said, at Holmusk, we're really trying to figure out how can we actually leverage data and look more deeper inside it, not just build a model to actually predict something and get a 0.99 score. What we really want to do is that what can we actually deliver for pharmaceutical and healthcare practitioners to be able to do better diagnosis, better treatment, or drug discovery. So what I just explained is actually our phase 1, which is AI for imaging. And the data that we'll actually get from these imaging will be incorporated in a bigger model called a quantitative systems pharmacology. Now that's based mostly on ordinary differential equation, but it's a dynamic model that uses both neural networks and AI. And then we can predict it. So clinicians or physicians can actually look into virtual clinical trials and be able to target specific molecular pathway. So this is why we're actually working in a group to really leverage into biology as well as data science and every single tool that we can. So this is my team, and these are my team members who will probably pop into the camera soon. So let's get into Q&A. I can't hear anything yet.
Hi, sorry. Thank you, Pascal. And that was great, insightful sharing. We've got our live chat that's open for you to actually ask any questions that you have for the speaker. If you don't have them right now, you can also put your questions in and the speaker can come back to you later as well. Okay, seeing that we don't have any questions for the speaker, which is always a good sign, that means that she's very clear and has got all her point across. We'll also be sharing the deck with you later. So thank you, Pascal. We'll move on to our next speaker. So next up, we have Priya. She's the CEO and co-founder of ExploreMaps. So today she'll be sharing with us about what are the data that you need in a startup, what should you measure, how quickly can you measure? I'll let her tell you all about it. Over to you, Priya.
Hello. Hi, I am Priya, short for Priyadarshini Majumdar, and I am the CEO and co-founder of ExploreMaps. Today, I'm going to talk to you about my journey with ExploreMaps, how we built our data pipeline, and how we ended up measuring what's relevant to measure. I will start with a nice story. This is how ExploreMaps began almost about a year ago. Once upon a time, there was a solo traveler, happened to be me, who was walking along the streets of Barcelona. Phone or a map in hand, she walked along the streets of the old town and lost, didn't quite know what she was seeing. Isn't that pretty much like all travelers? The next day, she was lucky. She found a local friend, and then he decided to take her around the old town. She said, "Yeah, I was just here yesterday, I saw this building, it's quite old." He laughed and he said, "Of course it's old. This is where Pablo Picasso studied art, right in this building." He took her hand and put it on the building, and he said, "There you go. You've just touched 14th century." That was travel experience. And I wondered, why couldn't technology tell me this before? I got together with a group of wonderful people and we built what we call today as ExploreMaps. So let's forward 1 year since then. We just launched the beta version of ExploreMaps, and ExploreMaps is a visual travel planner for the social explorer. So what is it really? These are microblogs that are plotted on a map. So that way, information, especially travel information, is organized in one form. This travel information can be created by anybody. So if you are a travel enthusiast, if you know some interesting trails in Singapore, you can go onto the platform and you can create it. And this content can be shared and published. And basically, you can tell everybody about what you did. So now, no more spreadsheets, no more Google Sheets about how you actually share information. I will give a little demo of the product so you understand what the product is about and how the data comes from there. So this is just giving you some background. So what you see here is I just made a search for Singapore, and this is all the trails that has been put on Singapore. One of our core technologies that we are using is Google Maps here, and we're using Google Places API to extract information about the locations and then plotting it onto the map. And we think this information, when put onto the map, really benefits travelers in the sense that they don't have to get lost all the time. And since they come with little microblogs, you can understand that, oh, this place is actually good for this and not for that, etc., etc. So given this in perspective, I will go back to my presentation where I want to talk about how we ask the relevant questions to build our data pipeline. Let's go back 6 months from today. We had this grand idea in mind, we had the vision of the product in mind, but we had one big question, and that is, will people use what we're building? And we had to break this, in order to get answer to this question, we had to break this big question down into much smaller questions. At that point in time, which is 6 months from now, we had one MVP, and we had a couple of questions. First of all, how do we know what our users doing on our product? This was the quantitative analysis. Second, how do they perceive our product? This was the qualitative part of things. And finally, how do we get hold of this information as fast as possible? Today, in this presentation, I'm going to talk about the first and the last, the quantitative, as well as how we did and how did we get to market very soon. All right, so those were the two questions, and we started categorizing our application and started understanding how we can answer these questions from the user perspective. So this is our user of ExploreMaps. And we divided them into two different significant kind of users. First is the viewers, and second are the creators. Viewers are travelers who like to look at information, who want to see the content, and they are consumers. Creators are those who want to put information onto our app. How do we measure our users? What are the relevant questions that we need to ask our users? So we thought that maybe one of the most important thing that will show their interest in our app is how are they interacting with the content, how many times pages were loaded, what are they searching for, where is the user journey dropping off? So that was from the viewer's perspective. From the creator perspective, are they creating trails? Are they publishing trails? Are they sharing trails, etc.? And then we took these questions and we mapped it to the most significant pages in our app. For example, the Trails view page, the newsfeed page, and the search page was very relevant to viewers. Trails view page was the page where people would view the trails. Newsfeed page would be the page where people are looking and searching for different countries and what all trails are there. And then finally, the search would be what kind of cities are they searching for. I'll tell more about this in detail in the next slide. It was similarly with the creators. We broke these questions, these smaller questions, down into quantifiable values. And what you see here is the existing measures that we have already in place today. For example, in the Trails view page, scroll count is important because that showed engagement, that people are scrolling and they're looking at content. On the newsfeed page, there's not just the scroll count, but likes on trails. So if there are certain trails and people like it, are they pressing it? How many times are they pressing it? And then second thing was, are they opening these trails up on a map or not? So that again showed the newsfeed page, the interest in the newsfeed page. And finally, the most crucial one was search. So what countries are they searching for, and where do these users live? This information put together gave us our daily active users. So number of page counts, scrolling count, and that happening on a daily basis gave us our daily active users. So now that was from the viewer side. We have something similar from the creator side, but from the creator side, we are trying to measure more of emotional investment into the product. So the number of times someone created a trail, from where did they create the trail? Did they publish it? How many times did they publish it? And whether they're editing, revisiting the trail back. So this is also directly linked to the probability of retention of the user on our product. Now, all of that was what and how, yeah. But what we needed to do now was how can we build it up fast? And what tools should we use to get to the market? Because as an early stage startup, you have money constraint and you have people constraint. So you have to put a lot of effort in building the product, and you cannot possibly put a lot of effort in figuring out how you're going to measure and building that side of the analytics and pipeline. So keeping this thing in mind, I'll show you how we did it. This is our tech stack, a very simplified version. our front end is React.js. We have a Django backend, and we use a MySQL database. This is for the beta product that we have online right now. Every interaction on the React.js front end was passed down to Segment. Segment, I'll tell you more about it, but for now, you can assume that this is our data layer. And from Segment, you can connect it to any kind of tool that you want to. We largely use Amplitude. Amplitude is what we use for data visualization, and MailChimp is mostly for welcome emails, etc. So now, why Segment, and why did we go for Segment, Amplitude, and not something else? So Segment is a third-party application. What they do is data integration. They have built up these integrations with so many services, not just Amplitude. They have it with Google Analytics. They have it with RDS, have it with Amazon, different services in Amazon. So you can actually build up a data lake. So what this did was it gave us just one bit of code that we needed to always focus on, which was the Segment API connection, and we didn't need to bother about any other integration. So in future, if I want to, let's say, put in some other kind of tool, all I need to do is integrate it with Segment, and it's just a one-click integration. So this is how we ended up building this data pipeline as fast as possible, and it took us like about 2 weeks from start to finish. What I'm going to show you now is an example of how we do it. And for example, the code on the newsfeed on the left that you see here is that of the div on the newsfeed. So one of the measures that we have is scrolling. So we have a non-scroll function, and we're measuring this on-scroll function. And this handles, so this goes to this thing called handle scroll, which is also another function which calls one of this particular key function, which is track scroll. Now, what is important here is the event name, the path, and the city. So if somebody is searching for Singapore on our app and it's scrolling, then this event gets passed. So it says that, okay, somebody's looking for scroll. It is coming from path newsfeed page, and they're looking at city Singapore. And what happens here is this track scroll 2 is eventually just JavaScript function, a JavaScript script, and it passes the event name, the path, and the city to Segment. So that's how we send data to Segment. What happens after this is the visualization on Amplitude. So this is just a simple screen, one of the simple dashboards, where you can see all the different events that get loaded, from scroll to city search, navbar, navigation. At this point, I will just do a short demo of, or I'll just show you what kind of dashboards we have built. As you can see, this is what I just showed. But some of the interesting things are when you go down, you see that people here, this is our what do users search for. As you can see, people look for London, Mumbai, Georgetown, Dubai. And for an early stage startup like us, this is real market research. This is primary data. So we know what people search for. We also know where they're coming from. And that helps us build our content and do target marketing. So so this is just basically an overview of all the dashboards that we've built out of just one integration. Finally, I would just like to come back to an overview slide, which is called the Delta framework. The reason why I put it here is to give a perspective of where the industry is versus where a startup should be. I myself have worked in 2 different banks and a financial service company, and I've worked in their data teams before. So this Delta framework came about to identify what stages different companies are on. So for example, as you see here on the first column is stage 1, which is analytically impaired, where there is really no data and people are not using the data that big companies are that is already there. So that's stage 1 to all the way to stage 5, where you have analytical competitors. This might be a little small for you to view, but when you see the deck, you can also Google it. There's lots of information on the Delta framework. These are the success factors that they look at, whether the leadership is taking analytical competence very, very seriously or not. And based on all of this, it shows you where everybody tends to be. So in the last 1 or 2 years, what I've noticed working in different financial organizations is that the leadership has definitely moved towards analytical competence, but the biggest challenge that these guys have now is putting data together. But I think they're also getting there. So they're moving towards stage 4, where they are integrating and getting accurate, good quality data in one place. And eventually, they're also looking for professional analysts and they're giving a lot of attention to data science and data analytics. So compared to that, where ExploreMaps is, it is on stage 5, largely because we cannot do without data. Data is our only source of truth, and this is how we know if users like our product or not. Getting back to the very first question. Well, now it's time for some Q&A.
Thanks, Priya. Very valuable information and best practices for when I plan to build my next startup. So we've got a question in the queue in the live chat session. Lightning Streak asks, what are some other alternative tools of Segment? Is that the only tool that you use, or is that what you recommend?
I would recommend that because, first of all, I think you're asking me because you want to start a startup. I'll just answer it from that perspective, though. Segment has a very good 2-year startup plan. That's one of their really big pros. And secondly, they have so many integrations. If you just open up Segment, you will see the number of services that they're integrating with is a breeze. And I think it is totally worth the money. I haven't found any competitors so far to Segment yet. And yeah, that's about it.
Okay, well, looks like that's our only question for now. The question seems to actually stream in slowly. So, Priya, if you stay on the lookout on chat, and you're welcome, of course, to keep asking questions. Our speakers are here with us till 8:30, and they can help to answer the questions that you have. So, thank you so much, Priya, for this sharing. And next up, we have Archana. So Archana is a master's student at NUS and also an instructor at Udacity. So she'll be sharing with us about deep learning and how that is changing the game in the smart grid system, all about energy and deep learning in the energy sector. So over to you, Archana.
Hi, everyone. I'm Archana, and I'm a master's student at NUS, and I'm also a course instructor for Udacity and Intel for AI on the Edge course. Apart from that, I worked for 2 years as a machine learning researcher at Sama Technologies. So today I'll be talking about the game changer in smart grid systems, that is deep learning. I know this topic is a little different than what has been previously presented, and there's not a lot of talks on smart grids as such. So I wanted to take this up and showcase how deep learning is changing this. So today what will we cover is, we'll talk about traditional grids. We'll also talk about smart grids. We'll talk about challenges that are there to the current smart grid systems. We'll talk about applications of deep learning models in smart grids. And I'll show you a small experiment where I've actually used edge computing, which is also a part of deep learning in solar panels. And lastly, I will talk about what exactly could be explored next and conclude. So traditional grid. So I'll take an example from Singapore. The laptops that you've been charged right now, or wherever you're actually viewing this from, is all coming from a power system. So let us take the Senoko power station, which is present in Sambawang. So the generation is done using natural gas, and then there is transmission that takes place. It goes via a distribution station, and then goes to various users like industry, commercial, residential. This is how a traditional grid looks like. Now, what will a smart grid look like? So an important factor to remember here is that the smart grid actually has inclusion of renewable energy. What I mean by that is an inclusion of energy like solar, hydro, wind, etc. And secondly, it also has the advantage of bidirectional flow of power and communication. What I mean by that is, for example, if you were to install a solar panel in your house, you can actually feed the excess power back into the grid, thereby you not being a consumer, but someone who can give back to the grid as well. So there is bidirectional flow of energy as compared to a unidirectional, which was in the case of a traditional grid. So to quick wrap up, The traditional grid is where you have reliance on fossil fuels. It's unidirectional flow of power and communication. Customers have almost no say. What I mean by that is that you pay a fixed flat price, like you do right now for energy, and then you have centralized generation. There's only one particular generating power plant which gives you the power. Whereas when you come to smart grids, you can actually generate it through clean and renewable energy. This includes solar, wind, etc. And then you can have bi-directional flow, as I explained. And consumers are actually ending up being prosumers, giving back to the grid and also taking part in pricing schemes, wherein you can optimize what sort of prices you want since you're giving back to the grid as well. And then you have distributed generation since you have a lot of parties or a lot of people involved in the power grid. Now I look into the challenges to the current smart grid. So I have explained all about smart grid till now, but there are a few challenges where exactly deep learning could be applied and where deep learning could actually improve upon. So the first is that handling uncertainties and intermittency of renewable energy. What I mean by that is you can see this graph. For example, solar energy can be only generated during the peak times of the day, and then the graph is almost nothing. And similarly, wind can only be generated when you have a wind speed. Hence, there is uncertainty that is there. And even if you, when you look at the graph, you can understand that to meet the load curve demands is actually quite difficult with renewable energy. What I mean by that is currently renewable energy generates power which is quite less than what is the load demand. So we actually need to step it up by using power converters, etc., in order to generate more. Furthermore, there is the problem that we have immense generation of information that is being created by smart grids. So how exactly do you end up tapping into that information is also important. And furthermore, we need to design reliable decision making tools and control structure such that when you're even giving back to the grid, how exactly do you give back? How exactly is the control being done? Furthermore, if there are faults, can I prevent it? Can I use deep learning to actually predict it? Those are the things that are challenges to the current smart grid. That is what deep learning is going after. So let us see some of the applications of deep learning models in smart grids. First is CNN. CNN, as you very well know, and also from the first presentation from Pascale, this is used for actually identifying images in, it's an image processing neural network. And what do we exactly use it for in smart grids? So there's a lot of customer profiling which is done, wherein you do load profiling of various loads that are present by a customer. So that you can do, the classification can be done via using CNN. You can also use it to actually detect faults in electrical equipments. Now, all your power systems have wires going and they have insulation. Can you detect faults inside it? Is it possible to monitor that? This is what it is going after, and CNN can do that quite well. And recently, someone did it and they got around 93% of accuracy. Now, let us look into another model which is called recurrent neural network. So, with recurrent neural network, you actually feedback your output back into your input. And what it does is it actually learns a long-term dependency. A type of recurrent neural network is LSTM. So LSTM is actually used for load forecasting. So as I even explained before, now the load profiling of a person, you can actually predict it. Why are you using LSTM? Because it's dependent on time series. Also, you can also do renewable energy generation because, as I explained previously, renewable energy generation follows a certain pattern. In case of solar energy, can you predict that? Yes, you can. You can do it very well using LSTMs. Another model that can be used is reinforcement learning. Reinforcement learning is a little different than our other approaches. It's sequential in nature. What you do is, for example, you have a person here who's throwing a stick to a dog. Now, there are n number of ways the dog can go get the stick. How do you teach the dog the right way? You end up rewarding it for every positive action it takes. And that is called positive reinforcement. And you end up giving it observations for every negative reinforcement, a negative action it gives. So it is a negative reinforcement. So what exactly could it be used for in smart grids? It can be used for dynamic pricing. What I mean by that is that dynamic pricing is where the customer gets involved with the different pricing that takes place, and it's not always constant, and you have information which is not complete. In such cases, RL is really good. You have electricity trading as well, which changes from time to time because there are a lot of market operators involved and a lot of people involved in the same thing. That also could be, the rules can be governed by RL. lastly, you can also have battery storage. That is, you have energy storage systems that can be used, and you can actually notice the charging and discharging via using RL. So this gets me to my last segment, which is actually about detection of soiling in solar panels using edge computing. This was something that we did on our own in our lab at my university. So we actually had a problem of detection of soiling. So soiling is basically dirt accumulation that happens on solar panels. And people who actually own solar panels or are working in the field might know about this. That soiling actually decreases the PV efficiency. So it's important to detect it, and it's also important to actually end up cleaning it. And most of the cleaning that happens now happens through manual inspection, and then of course cleaning it via using maybe just piece of cloth or using cleaning techniques like over here. So what exactly how exactly did we go about doing it? So as any deep learning problem, first we collected the data set for all solar panels, soiling of all solar panels, and then we trained it on a HPC. HPC is like your high performance computing, which can include your CPU or your GPU or a TPU. And then we did inference on an HTPU. So I'll actually discuss about that. So the advantages of actually doing edge computing is the fact that you do not need to be dependent on the internet. So I do not, if I run my inference on the edge device, I do not need to send it to the cloud every time for inference. I can do it right there at the edge. And latency. Secondly, if the latency is not there because there is no connection to the cloud, so you do not send data back and forth. Everything happens right at the edge. Security, the entire process happens right at the edge, so you do not need to worry about your data being spread somewhere or spread back to the cloud or sort of leaked away. Nothing of that sort will happen, and your privacy is sort of maintained. And the devices are small, so obviously you won't have bulky devices like your GPUs. You have small devices that can be placed anywhere, like microcontrollers, and less power hungry. So like most of the devices like your GPU consumes around 140 watts of TDP, but the devices on the edge can consume just about 2 watts. So that makes it very ideal for inference. So I used an edge TPU, which is actually designed by Google, and it gives high performance ML inferencing for low power devices. And I also use something called the Coral Dev Board, which contains the edge TPU chip, and along with that, it contains a system on chip. And it is basically it's a complete system, and it looks something of this sort. So I noted the results for it. First was so I basically ran two main models on it. So if you're using an edge device, it's important you have algorithms that are suited for the edge. This is where I used a mobile net, and I compared it to using a ResNet as well, which is something that was explained by Pascale as well. It is pretty the network is pretty huge. So this is what the observations that I got via running mobile net. I actually got way less time for inference as compared to ResNet, but at the same time, you can see it takes very less time and it's very appropriate for using at the edge. So this brings me to the very end, and the conclusion out here is that deep learning has immense applications in the field of smart grids, and especially for forecasting and for trading. Wherein for forecasting you use LSTMs or RNN based models, and for trading, wherein you use reinforcement learning. And how can you get into the field if you're someone who's just starting off? And I started off like maybe 2-3 years ago. So how exactly could you start off? You can start off by implementing some of the algorithms that I said. Data set are quite readily available on the internet. You can go ahead and search for some open source data, and you can implement some of the algorithms that I state. But what exactly could be done in terms of further work? You can maybe utilize better computing devices. What I mean by that is now we have access to better processing power like quantum computers. So Google came up with TensorFlow Quantum just last week. So you can use that and try out maybe for using these problems. Smart grids especially have problems, microgrids especially have problems of optimization, and they have a lot of noisy data. Could that be utilized for quantum computers? And also there is adaptability. So you have to adapt your neural networks to be suited for the edge. And lastly, you can watch the work, and you can follow the work by different people in Singapore and universities like NUS. And I also know companies like Resync, which are constantly working on technologies like this. And yeah, this brings me to the very end. If you feel like contacting me, for resources, or maybe want to start off with this, feel free to take a picture of this or scan the QR code, and you can contact me in this email ID too. I would love to answer your questions, and thank you so much.
Thanks, Archana. We have a question from Soham. His question is, how are neural networks for edge than neural networks for GPU, CPU? How are they different?
So that's a good question. So the network is obviously a little smaller. For example, if you take the mobile net, it is actually way smaller than your ResNet. And it's also a transfer learning neural network. And so such algorithms can be actually optimized for the edge.
Okay, and we have one more question for you as well from Angela in the live chat. She asked, in the case of the soiling detection, what is the features?
The features are just the image that I got for soiling, and it also has the power loss feature, so it tells me how much power loss is being occurring. So that helps me actually determine the efficiency of the PV panel.
Thank you. I think that's our two questions for today, and we'll probably allow the audience some time to actually come up with their questions. But in the meantime, thank you so much, Chana, for joining us. That was a super insightful session. I'm glad that we also went into deep learning in our data science session. So thank you so much, Pascale, Priya, and Chana, for joining us today, our very first Lakopi Online. We want to hear all of your feedback. Thank you for all the audience that stayed true all the way with us. This is our first online event, and we really want to hear what you thought and if there's anything that we could do better to make the next one even more interesting. So go to our feedback form here, and you can fill out the feedback form. And our next Lakopi open mic will be on the 15th April. If you or your team is working on solving for solutions related to COVID-19, we really want to hear all about it. So nominate yourself as a speaker, and we look forward to hearing what you're working on and sharing it with the community as well. So last but not least, if you want to know what are all the events that we have happening here, connected with us, sign on to our mailing list on our website, or follow us on Facebook and Twitter. So stay safe, everyone, and we look forward to the day that we can all connect with you in person again. Until then, stay tuned for our upcoming events and join us online. Bye!